Hello there. As Halloween is closing in on us, I started watching my favorite horror movies. And one of my most favorite sci-fi horror movies of all times is 1979 classic Alien, the movie. Now, I mean, as an astrophysicist, it's sometimes difficult for me to watch sci-fi movies and not overthink about science and how realistic the science is. But I usually try to, when I see a movie that is not trying to be scientifically correct and just fun, like The Alien, I don't scrutinize the science that much. Whereas when I watch a movie like The Martian that is trying to be scientifically correct, then I turn on my astrophysicist eye and look at it closely. But I mean, I've seen Alien about more than 20 times, and I never thought about science so much. I mean, I had some ideas, but never scrutinized it that much. So I decided this year well, it's just an excuse to watch the Alien movie once more, but I decided to take a closer look at the science behind it. Now, and this is what I want to talk to you about today. And I'm not going to go into all the nitty-gritty details about all the little things that they got wrong in terms of science and so on. I just want to focus on the existence of this awful, terrible alien species, xenomorph, horrifying, and to think about, is something like that possible, that we encounter them in space if we ever find extraterrestrial life? And is such planetary system where this plot is happening possible? So let's dive into that. So a backstory. So if you haven't watched the Alien movie, I urge you to watch it, and to be warned, there's going to be spoilers, so spoiler alert. We're going to be talking and showing some gore graphic images, so if you're not into that, so stay alert. Maybe better to skip those parts. But I mean, the plot of this movie is set in 2122, so about 100 years from now, and we see this commercial spaceship Nostromo that's being stopped from its regular route and diverted to explore a mysterious signal that's been coming from a planetary system, and they go there to explore that and encounter this very aggressive alien species, and is trying to kill them, and the whole movie they're fighting for their lives. They're trying to stay alive. Now, it's amazing, actually. I mean, this movie, even when you look at it now, I mean, the visuals are terrific. I mean, it's no wonder that he got an Oscar for the visual effect. Oh, by the way, this is a movie by Ridley Scott. I mean, he's directed so many great movies, like the Blade Runner and Thelma and Louise and so on, and with the lead role, Sigourney Weaver in the leading role. Okay, so anyway, back to the story. So let's think about the world where this is happening. So the distress signal they picked up was supposed to be coming from a moon, one of the 3 moons that is orbiting a planet around in the binary star system. The binary stars in that system were yellow dwarfs, so stars like our sun, and there's a planet, and we see in a shot of the movie, there we see this planetary system. The planet has rings, so it looks something like Saturn. And this moon where they land to Acheron or LV-46 is one of the 3 moons. By the way, this planetary system is supposed to be some 39 light years away from the Earth. So what do we know about this moon that they mentioned in the movie, or that you can find online? So this moon is supposed to be a body that is about 600 kilometers in radius, or about 10 times smaller than Earth. Now, if you look at the bodies in our solar system that are of that size, for instance, like Ceres, the largest asteroid, they all tend to be sort of rough on edges, like bumpy, potato-like. And that's because, smaller bodies in the universe tend to be irregular shaped because of their lower gravity, and the massive, the bigger the object gets, it gets more round. So this, we see this in a shot of this movie. This world looks a bit too round for my taste, but we'll let it go for now. And one other thing is more problematic in terms of size. So we know the size of this thing, and then we see them walking on this thing, and they even say explicitly that the gravity on this little moon is 90% of Earth's gravity. It's almost the same gravity as an Earth, so they're not floating in air, so they're just regularly walking. Now, if you know your basic Newton's gravity formula, you know that gravity is stronger the more between bodies, the more massive the bodies are, and is also stronger the closer the bodies are, or the smaller the body is. So if we want on something so small, as 10 times smaller than Earth, to have the same gravity, same gravitational pull on the surface as on Earth, that would mean that we can calculate basically that the mass of that body, the mass of that moon, should be about 100 times smaller than Earth. So, okay, it's a smaller body, 100 times smaller than Earth. That seems about fine. But then you can calculate the density of that body, right? And if you look at the density of that body, it turns out that that density should be about 10 times denser than density of Earth. Now that's a bit extreme. That is the densest object ever, because of all the objects that we have in our solar system, or basically of all the extrasolar planets we found around different worlds, the densest planet found so far, one of the super Earths, is only about 2 times as dense as Earth. So a moon being 10 times as dense as Earth, that seems a bit too extreme. I didn't think we could find, I would be surprised if we could find such object with such other characteristics somewhere around, because that would mean that object, that planetary system, was born out of some maybe super metal rich cloud of gas to become so dense. Now, it was pointed out that, you might think that, well, maybe because when planets and moons and bodies form, basically the heavy stuff, the denser stuff sinks in, and the lighter stuff remains on the surface to create a crust of the object. So you might think, well, maybe, this object suffered through some major collision that stripped away its envelope and leaving out just bare core of that object, which is dense, and that's how this object got its density. And that would certainly explain one other property that we know about this moon, and they said in the movie, that it rotates really fast. It takes about 2 hours to spin once on its axis. Bodies of that size in our solar system take about 10 hours to spin. So this is really extreme rotation, and explains also the strong winds that they mention in the movie. But back to my story. So this fast rotation and this moon being so dense could be explained with just how this moon was formed, basically as being like remains of a core of the previous body. But one thing that will be problematic within this scenario, within that scenario, is that this moon, as they say in the movie, still has fairly dense atmosphere. So if such collision happened or something, they're having such dense or any atmosphere would be a bit problematic. And that is what is also mentioned in the movie, that this body has dense atmosphere of primordial composition, methane, nitrogen. It's very cold, carbon dioxide crystals, because it's cold, it's frozen. And also what we see, what's seen in the movie, shows the sunset or sunrise on this moon. It looks bluish. It's like sunrises and sunsets on Mars, where the sky is red, but the sunsets and sunrises are blue, like on Earth. because of the fine dust particles of which light scatters in moon's atmosphere. So I think they might have gotten their inspiration about this body from watching the moon. But again, from watching the Mars. But again, this body is fairly cold, so it's with dense atmosphere. So it's something like, maybe it's something like Titan, Saturn's satellite. It resembles something like Titan, maybe, but with sort of Martian sunset. Anyway, so my major problem with this body is it's basically density. Density and still keeping such atmosphere. So I think that's one of the other issues. Now let's talk about the alien. That's the main question. Now the alien movie, the horrifying, I mean, xenomorph, aggressive xenomorph species. I mean, the shock when we first see them, it's awful. I mean, really terrible. I mean, the scariest part is they don't have eyes. I mean, that was done on purpose, so that they would look scary, as if they weren't scary now, being more than 2 meters tall and with strong, like, body, almost like armor, hanging like armor that it's almost like Kevlar. I mean, they shoot bullets at it in later movies in the sequel, but it's really tough even to penetrate with bullets. But they're flammable and still they're scary. But the most interesting thing about this alien species for me was that they have, I think that was a major shock also in the first movie, was that they have acid for blood instead of blood. And when they cut through this alien, I mean, the acid leaks in and then punches a hole through the ship, burns a hole through the ship. And what kind of alien species would have acid for blood? Come on. And well, I would guess some species that grew up and that originated from a planet where acid is normal. And one place in our own solar system comes to mind, and that's Venus. Venus, it's almost Earth's twin compared to size. It has very dense and very thick atmosphere, but very inhospitable atmosphere because, I mean, first, very dense, high pressure, and so on, but it has clouds made of sulfuric acid. And that's really nasty. That could be a problem, right? And so I could imagine that, you know, if there was a system, a body out there that had such acid all over the place, that, you know, if any life evolved there, it could be basically such extreme life form, like extremophile, so that they could sustain, even maybe have acid for their blood. That's actually interesting with all the talk about possible life in the possible life existence on Venus that's happening these days because of the traces of compounds that they will find possibly found in their atmosphere. But more on that, about that. That's another topic. So let's get back to extremophile. So yeah, I could imagine some alien like that happening with having acid for blood. But what is the main problem for me about this alien species? It comes from the major scene in the movie. The most shocking, terrifying scene is when we first take a look at this alien, when it rips the rib cage open of one of the crew members and punches through him. With all the blood and gore and so on. And one question comes to mind immediately is, and we see this alien, which it looks scary, but it's a tiny thing. It has maybe 5 kilos on it. I don't know. It's yay big. And we see it punch through a rib cage. Now, cracking a rib cage is not easy. I mean, it doesn't happen every day. I mean, you don't fall just and crack a rib or, you know, crack open a rib cage. It takes significant amount of force. Now, boxers can do it. Maybe not even always. It takes more than 3,000 newtons of force to possibly crack a rib, let alone crack open entire rib cage. But let's assume, you know, let's be generous here. Let's for the purpose of argument, assume that 3,000 newtons is sufficient to crack the entire rib cage open. Question is, can this little baby xenomorph do it? Boxers can do it, so maybe this baby xenomorph can do it. Okay, so what's the main difference between a boxer and this baby xenomorph? So weight, right? So if boxer could have 100 kilos on him, baby xenomorph maybe has 5 kilos on it. And for both of them to deliver same amount of force, and when you look at the strength to mass ratio, I mean, this little guy, this baby xenomorph must be much stronger. Because we never look at the strength, in absolute terms. Sure, I'm stronger than a bug, right? But we always look at the strength compared to mass, to stress, the strength of an organism compared to its mass. Like, how much of your body mass can you lift? So, if you look at the world records of weightlifting, I mean, they can lift, I don't know, 15, 20 times their mass, right? But a dung beetle, dung beetle can lift about 1,000 times its own mass. So dung beetle has this much larger strength to mass ratio than humans. And that's naturally how it happens. The smaller the organisms are, they have higher strength to mass ratio. The reason behind it is your strength comes from your muscles, right? So muscles cover the surface of your body, right? And your mass comes from everything inside you, so from volume of your body. So when you grow organisms in size, so when you double the size, so think about, don't think about arms and legs, think about, Lego man, like square people, it's easier to think about it. So if you double something in size, the surface of that thing would go as size square, while the mass and the volume of that thing, that organism would go as size cubed. So your mass will grow much faster than your strength, So when you grow organisms in size, their strength to mass or surface to volume ratio will drop. And that's why smaller things have higher strength to mass ratio. So, if when we compare the humans and dung beetle, for instance, dung beetle has 50 times stronger strength to mass ratio than humans. So let's look at this little guy, baby xenomorph. If he's cracking open a rib cage and delivering 3,000 newtons of force, that will mean that because it's that much smaller, it has 5 kilos on it approximately, that will mean that the strength to mass ratio of this baby xenomorph is like 20 times larger than of boxer. And you might think, oh, okay, that's reasonable. Dung beetle has 50 times this ratio. I would say, okay, yeah, that might be true, but this guy is too large. Dung beetle is much smaller. So how could he have sustained that large strength to mass ratio and become so large, especially if that species evolved on a body that has gravity similar to Earth, right? I could imagine, for instance, if we said like that the xenomorph originated at a planet, at a different place where the gravity is much stronger than on Earth. That was the original idea behind, for instance, Superman comic. That Superman didn't fly at first. The idea was that he just grew up on a planet that had much stronger gravity than Earth. So his muscles were used to, opposing and fighting that gravity. So when he came to Earth, and this was a piece of cake. He wanted to walk, but he would jump over tall buildings. So if xenomorph originated from a planet with a much stronger gravity, then I would go, okay, maybe that strength to mass ratio is reasonable. But if it originated at that body, at LV-426 body, then I don't think that is plausible. Another even more problematic issue with this xenomorph is when we see in the movie, and if you look at the timeline, essentially, so this little guy, baby xenomorph, punches through the chest and runs around, and sometime later, we see this full-grown monster xenomorph in full size attacking a crew member. So you can think about the time difference between it being born and being full-grown alien species. And it takes about, I guess, in the movie about a day or maybe a few days, but it's definitely not more than 2-3 days, right? And so suddenly you have this baby xenomorph, 5 kilos, growing to full-grown xenomorph of more than 2 meters tall and more than 100 kilos on it. The question is, how does it grow from 5 to 100 kilos in a day? I mean, to grow, you need energies, you need calories, right? You need food. We basically need about 3,000 kilocalories calories to gain, half a kilo of lean mass. So if he were to grow, 100 kilos in mass, essentially he would need to ingest about 500,000 of kilocalories. So he would need, about 60 kilos of food. Now, in the movie, we don't see any crew member eaten before this main attack scene. There's this cat running around, but cat is alive, so they don't complain about their fridge being broken open or, food missing. So maybe, the species is eating through the hull of the spaceship, eating metal. I don't know what it eats. But yeah, that's a valid question of, the alien's diet. What does he eat to grow that much? But even worse is the growth rate. I mean, to grow, even if there was food, even if there were 60 kilos of food that he found somewhere in a storage room that someone forgot, how did it grow in a day from, yay big to about 2 meters? It takes humans, for instance, to go from baby to about 180 centimeters, let's say 18 years. And this guy grows, to about that size in like 24 hours. So human rate, about 10 centimeters per year versus alien growth, 10 centimeters per hour. That's the fastest growing thing ever. The fastest growing vertebrate on Earth, African killifish, grows about 1 millimeter per hour. And this alien is supposed to grow 10 centimeters per hour. Fastest growing plants, giant kelps, algae basically, or bamboo, they can grow 4 centimeters at best per hour. Again, this thing grows 10 centimeters per hour. So this is some, insanely fast growth rate, and with such fast metabolism, and compared to everything we know, all the life we know on Earth, this to me doesn't seem plausible. So looking just at those two things, my verdict is existence of such alien species like Xenomorph in the movie, 1972 movie, 1979 movie Alien, doesn't seem plausible, because the world where they originated doesn't seem that plausible. And something that is so strong, that came from a body of Earth's sort of gravity, is so strong with such fast metabolism, such fast growth rate. It just doesn't seem real. And you can sleep soundly and not be scared of these aliens. And frankly, probably if we ever find extraterrestrial life, we're most likely to find like some lower life forms, some primitive species, and that actually might be even scarier. So that's it for this Halloween. Have fun.